Chances are you've seen the sun shine brightly in the sky, or watched a bolt of lightning strike the earth during a thunderstorm, or raised and lowered a window shade. Do you know what these things all have in common? That's right, they all involve energy. Energy is all around us and is involved in almost everything we do. We use energy when we eat, or when we run, and even when we breathe. During the next few minutes, we're going to study the different forms of energy and the role energy plays in our lives. Energy is defined as the ability to do work. Every time we do work, we use energy. When playing sports, we use a lot of energy and are often tired when we're finished. We are working all the time. When we pick up a heavy object, we exert a force over a distance to move the object. We're doing work. An object may gain energy as well. When we hit a tennis ball with a racket, we're giving the ball energy to travel to the other side of the court. Energy comes in many different forms, but there are 5 main forms which are commonly used in everyday life. Let's first take a look at one type of energy with which you are very familiar: mechanical energy. You decide. What do the following things have in common? These race cars, this skateboarder, and this stream. That's right, they're all in motion. When an object is in motion, it has energy. Energy associated with motion is called mechanical energy. The wings of this bird exhibit mechanical energy or energy of motion, enabling it to fly. Moving waves in the ocean also exhibit mechanical energy. Most machines use mechanical energy to get certain jobs done. The mechanical energy of objects that are in motion is also referred to as kinetic energy. Kinetic energy is the energy of motion. We'll discuss kinetic energy in more detail in a few minutes. You decide. Where does nuclear energy exist in space? The star from which we get light, our sun, produces nuclear energy. Nuclear energy is energy trapped in an atom. This is a model of an atom. The nucleus is the center of an atom. This is where nuclear energy is stored. The type of nuclear energy that occurs in the sun is called fusion, which is the result of the joining of nuclei of 2 hydrogen atoms. Nuclear energy may also be released when the nucleus of an atom splits apart. Fission is the process of splitting the nucleus of an atom into smaller nuclei. When the nucleus splits apart, a great deal of heat energy is released. In nuclear power plants such as this one, the heat from the splitting of uranium atoms is used to heat water to create steam. The steam is used to spin large turbines like this one to generate electricity. The energy released from the nucleus is the most concentrated form of energy existing today. Have you ever rubbed your hands together on a cold winter day? If so, chances are you felt your hands warm up. When you rub your hands together, the friction between your hands causes mechanical energy to convert to a third form of energy, heat energy. All matter is composed of atoms, tiny particles that remain in constant motion. Heat energy is associated with the motion of these particles. When the motion of these particles increases, the amount of heat energy they produce also increases. Cooler objects, such as this brick, contain particles that move relatively slowly. But warmer substances, such as steam rising from this cup, contain particles that move faster. Heat energy is responsible for changes both in temperature and in phases of matter. As you probably already know, it's possible to measure temperature of objects with a thermometer. Ice has less heat energy, and therefore has a relatively low temperature of 0 degrees centigrade or less. Whereas this cup of hot water has more heat energy and has a temperature between 60 and 70 degrees centigrade. Heat energy is also responsible for phase changes. A phase change involves matter changing from one phase to another. For example, water can exist in the form of solid ice, seen on this lake. But when ice is heated, it changes to a liquid. And if liquid water is heated even further, it changes to a gas, as seen in this steam coming off the surface of the hot water. Chances are you've watched an ice cream cone melt on a hot day. The high temperature causes the atoms to move more quickly, producing more heat energy, which results in the ice cream melting. As we've already learned, matter is composed of tiny particles called atoms. Bonds like these between atoms make it possible for substances to form and hold their structure. Within each of these bonds is a certain amount of energy. The energy within the bonds that holds atoms together is called chemical energy. When wood is burned, chemical energy is released and converted into heat energy. Fuels such as gasoline and diesel fuel also contain chemical energy that, when combusted, propel large machinery. And when certain chemicals are mixed and then ignited, the chemical energy is converted to heat and mechanical energy that has the ability to move huge slabs of rock.
You got it?
We gain and use large amounts of chemical energy every day. Our bodies gain chemical energy every time we eat. When we digest food, the bonds between atoms are broken, releasing chemical energy. When we kayak down a roaring river or snowboard, we use the stored chemical energy we've gained from food. You decide. What causes this bulb to give off light? The bulb is lit by electricity flowing through the thin piece of metal in the bulb. The energy associated with moving electrical charges, such as in the light bulb, is called electromagnetic energy. All matter is composed of atoms. But did you know that atoms are composed of many smaller types of particles, one of which is called an electron? The red dots orbiting the nucleus are electrons. Electrons carry an electric charge. When these particles move through materials that conduct electricity, such as the metal in the light bulb, it's converted to light and heat. Electromagnetic energy is all around us, and we use it every day. It's carried through power lines in the form of electricity. It's used every time we turn on a computer. And it's even in lightning. What do this hammer, this spatula, and this baseball bat all have in common? These three objects are all doing work on a second object. The hammer is forcing the nail into the wood. The spatula is flipping over the egg. And the bat is hitting the ball. Since these objects can do work, they have energy. And since the objects are in motion, this energy is called kinetic energy. Kinetic energy is defined as the energy of motion. You decide. Which has more kinetic energy? This tennis ball or this truck? That's right. The truck has the most kinetic energy. The amount of kinetic energy an object has is directly related to both its mass and its velocity. The equation for kinetic energy is as follows. Kinetic energy equals mass times velocity squared, all divided by 2. Would you rather be hit by a tennis ball tossed towards you lightly, or a tennis ball hurled toward you with great speed? Hopefully, most of you would rather be hit by the ball which was lightly tossed. This is because it has less kinetic energy. Have you ever sat at the top of a slide or prepared to skateboard down a ramp? If so, you've experienced potential energy, the second state of energy. Potential energy is stored energy. It is also referred to as the energy of position. When you're at the top of a slide, your body has stored energy waiting to be released when you go down the slide. This stretched rubber band has potential energy, and when released, is flung outward. Potential energy also exists in foods. Food contains stored chemical energy, which is released upon digestion. You decide. What type of potential energy is dependent on the height of an object above the Earth's surface? Any object above the Earth's surface has gravitational potential energy. This bridge has gravitational potential energy, as does this airplane. The equation for gravitational potential energy is as follows. Gravitational potential energy equals weight times height. As the weight of an object and its height above the surface increases, so does its gravitational potential energy. Perhaps you've heard the expression, the bigger they are, the harder they fall. This is true of gravitational potential energy. This large tree has more gravitational potential energy than this small tree. Let's see what happens when we cut down this small tree. As you can see, it came down with a small force. But when we cut down this large tree, it comes down with a large force. We've already learned that there are 5 main forms of energy. But did you know that these forms of energy are interchangeable? Energy is able to be converted into many different forms. When you rub your hands together, mechanical energy is converted into heat energy. And when you light a match, an energy conversion occurs. When the match head is rubbed against the box, mechanical energy changes to heat energy. The heat energy causes the chemicals in the match head to ignite. Chemical energy is then converted to heat energy that we can feel and light energy that we can see. During photosynthesis in plants, electromagnetic energy from the sun is converted into chemical energy to be stored in the plant. Energy can also be converted from potential energy to kinetic energy and vice versa. Almost everything in this world can be created or destroyed. Can you think of one thing that cannot? That's right, energy. The law of conservation of energy states that energy cannot be created or destroyed, only changed in form. Take a light bulb, for example. Have you ever noticed that a light bulb gets very hot when you turn it on? This heat energy is formed from excess electromagnetic energy, which was not converted into light energy. No energy was lost, it simply changed form. During the past few minutes, we've discussed energy. We identified the 5 different forms of energy, including mechanical, nuclear, heat, chemical, and electromagnetic energy. We investigated kinetic energy and the factors it depends on, mass and velocity. We studied potential energy as well as gravitational potential energy. We also took a quick look at energy conversions and explained the law of conservation of energy. So the next time you flip on a light, eat a piece of food, or go for a run, take a minute to think about how energy is involved in your life. You might just think of energy a little bit differently. Fill in the correct word when you hear this sound. Good luck, and let's get started. Number 1. Energy is the ability to do. Number 2. Energy is energy associated with motion. Number 3. Energy exists in the bonds that hold atoms together. Number 4. Electricity is an example of energy. Number 5. Energy associated with the motion of atoms in matter is called energy. Number 6. Energy is released from the nuclei of atoms. Number 7. The two states of energy are energy and potential energy. Number 8. Energy is stored energy. Number 9. Potential energy is dependent upon an object's height above a surface. And number 10. The states that energy may not be created or destroyed, only changed in form.